Hi, my name's Ben Marcus, and I'm really excited to be here today. I'm going to tell you a little bit about how we use Splunk to gain visibility into our global high-performance computing grid. And I'm hoping you'll learn some techniques that maybe you could take back to your environments or might spark some ideas that you may be able to use for your situation. So I'm a senior staff engineer at Qualcomm Incorporated. Probably seen this 100 times by now. It's the mandatory slide from legal. Basically says anything I say may not apply in the future. You could ignore it. I've never actually read the full thing, though. So a little bit about myself. My background is actually software engineering. Developed software for many years. In addition, I've worked in large-scale system administration for over 20 years. And I've been fortunate enough to have been using Splunk for over 8 years. Fun fact, I've actually been on every Splunk conf, and it's really exciting to see the continued growth of the conf every year. So hopefully that trend can continue. If you'd like to connect with me, feel free to reach me at LinkedIn. My information's right here. So a little bit about Qualcomm, in case you don't know. #1 fabless semiconductor company. Basically make lots of wireless telecommunication. Probably a lot of the phones you have here have some chips from Qualcomm inside it that power it. In addition to phone technology, Qualcomm also makes wireless telecommunication equipment that goes into other things like connectivity, routers, IoT, automotive, servers. So to make all these chips, it requires a really complex IT infrastructure. We have a lot of servers. So let me paint you a little picture about what our environment looks like. So we've got thousands of servers globally connected, running engineering jobs 24/7. Multiple data centers, multiple sites. Hundreds of file servers, hundreds of thousands of jobs from engineering every day. Hundreds of Ldap servers, Active Directory servers. It's all tied in with job scheduling software, multiple clusters, multiple sites. Of course, all these jobs, they take licenses, so we got tool license servers. We've got integration with revision control systems, multiple type of revision control, and the users themselves, they interact with the environment through their virtual desktops. So we've got thousands of virtual desktops. The point I'm trying to make is that it's big and really complex. Does anybody else here have a big, complex environment? Yeah? Okay, good. So before Splunk, users may submit a ticket, hey, my job is slow, or everything is broken, or nothing's working. And then the managers start getting questions. Well, who did it impact? When did it start? When are you going to fix it? What's going on? Does anybody sound similar to your environment? Okay, great. So I see a few nods. So really, we needed a way to have more quantitative information and answer these questions a lot quicker. So that's when our journey to Splunk sort of began. We needed to quickly be able to drill down into this global engineering environment, what was going on, what was it affecting, and really start answering questions. And instead of just guessing and pointing fingers in the war rooms, we needed data. And we needed data that everybody could look at consistently. So what did we do? Well, we brought in Splunk. Step 1, we added our data into Splunk. So Splunk, of course, is very good at taking machine data and understanding what's going on. So we deployed the Splunk forwarder by default on all of our hosts. Brought in as many logs as possible. So for example, all of our Unix Sis Logs, the Ldap servers, all of the Ldap access logs, Active Directory logs, filer logs, networking logs, load balancer logs, revision control logs. Whatever we had in our environment that was affecting the grid, we brought in those logs. So this started giving us the visibility. And for those of you new to Splunk, basically we have a lot of different source types. So we're bringing the data in across the environment, as many logs as possible. Our out-of-band managed server logs. So for example, if you have HP or Dell or Quanta or Supermicro or any type of server, usually these systems have some sort of out-of-band management system as well. So we brought in those logs as well. Data center information, temperature, power. These devices that control the data center, they have logs. We brought in those logs. So many type of source types. If you're familiar with Splunk, how many are sort of new to Splunk? Okay, some people, all right. So Splunk has technology add-ons and apps. If you go to apps.splunk.com, they'll allow you to bring in different type of data, and they understand the format of the data with predefined fields. So there's something that Splunk provides called the Unix technology add-on. Well, a while back I developed something very similar, but it had some additional sources. So we brought in a lot of information from our Linux systems, data from the Linux proc file system. How many folks are familiar with Linux here? Some people? Okay, great. So there's a lot of data in the Linux proc file system that's very useful. So we brought that information into Splunk. For example, mounts. What's mounted? What were the mount options used? In addition to the logs, we brought in user tickets. So all the user information that we could. So when users submit tickets to IT, we brought that information in. We wanted to be able to see trends of the type of tickets coming in. Change requests. A lot of times there would be an outage after a change occurred in the environment. So we wanted to be able to correlate that, and we brought in the change tickets. And of course, any major outages we have, we track those as well, and we can see that information in Splunk. So we brought in our logs, we brought in the ticket information, and finally we added metrics. So metrics, values over time, numerical type values, counters, load, CPU, network stats, traffic in, traffic out, file systems mounted, those type of stats to see a trend over time. So if there's something that differs, things can spike up, we can help spot those trends. So for those that said they're somewhat familiar with Linux, let me show you what we have here. So these are just sample Sis logs. And in Linux, if you have NFS in your environment, the Linux Sis logs will basically log a message, NFS server, server name not responding. So I've had to black out the actual server names here, but this is just a basic Splunk graph in the search showing some sample results for NFS not responding. So think we have thousands of servers all around the globe. We could easily search Splunk and see across all of our servers how many NFS not responding messages we get. So that's what I'm trying to show here in this slide, and it's probably kind of hard to see in the back, but being able to see data in aggregate is very powerful. Across all of our servers globally, we could see how many servers are logging the message NFS not responding and which file server it might be. And you could see in the top graph I've had to highlight or remove the actual filer names, but 94% of the messages, you could see this bar chart sort of sticks out, come from one particular file server. So very easily with Splunk out of the box, just by putting your logs in, you could start seeing trends of what's happening over time. Here's a very same data, but just in a basic time chart format. So the graph on the top, and it's a little hard to see, so I'll just kind of walk you through it. The y-axis is just the number of unique hosts that are logging NFS not responding, and the x-axis is time. So you could see around 12:30 p.m., suddenly we got 600 hosts all logging the same message. So good clue there's something going on with that file server. The graph on the right is same data, NFS not responding messages logged from the Linux kernel, except it's the total number of messages. And the reason why we have two graphs is because this allows us to determine if we have 500,000 messages, are they all coming from one host, or are they coming from thousands of hosts? Is the problem limited to one machine, or is it coming from hundreds of machines? If it's coming from one machine, then there's probably a problem with just that one server. If it's coming from hundreds of different machines, there's probably a problem with the file server. So having both pieces, the same message, but distinct count versus total count, tells us very easily what's going on. Here's the same data again for NFS not responding for our filers, but just in a colored time chart. Now, each of the colors corresponds to a different filer. So you can see around 12 p.m., we had over 2,500 hosts logging NFS not responding. So something was probably starting to go on in that server. Now we also had a smaller green filer that also had a similar situation. So we had two different situations at once, but we could easily see the two filers here. And the bottom graph, again, is just the total number of messages. So almost 100,000 NFS not responding messages, but it was basically for two different filers. So the power of aggregating all your data and being able to see across all the hosts, that's really what Splunk easily can give you. Let me give you another example of data aggregation. So this time, we're going to look at Ldap logs. What we've done, again, is all of our Ldap servers, we've put the access logs and those error logs in Splunk. So we could quickly query Splunk and see across globally all of our Ldap servers what's happening. Now, even if you don't know anything about Ldap, Splunk right away will tell you one host has 98% of the messages. So I've had to eliminate the host names here, because those are super secret. But you could see the top bar graph there, the top graph, 98% of the messages. So in this case, what happened was SSL certificate expired on one of our Ldap servers, and then that was causing cascading failures downstream. But we were able to quickly determine which server it was just with the Splunk out-of-the-box statistics. Here's one more example of data aggregation with Ldap, but this time, instead of Ldap messages, what we've done is we've instrumented our filers to send their Sis Logs into Splunk. So all of our filers log the Sis Log stream into Splunk. So again, we can quickly search and see if there's a common pattern emerging. In this case, when the Ldap servers had a problem, this was the view that the filers started making these messages, saying Ldap server basically not accessible. Again, the sudden spike up, 3,000 messages at the top, just shows you when the incident started and that something was going on. Normally, we never get this message. Suddenly, it spikes up when the problem with Ldap occurred. And again, we know when the problem was resolved, when the messages went down again. So it's giving us that quantitative information very quickly, but this time from the perspective of our filers, which depend on Ldap. So we're trying to get perspective from multiple sides, the filer side, the storage side, the host side. And we can do that with Splunk because it can handle multiple source types. Let me give you another way we've used Splunk in our environment. And this is to really help understand workflows and how users are interacting with the IT infrastructure. So we had some users call and say their files were being removed. And they wanted to know why IT was deleting the files. Well, we don't normally go out and delete files from users. So first of all, we use Splunk to confirm, did files get removed? In our environment, on our storage servers, we're able to log file accesses, removes, renames, creates, things like that. So we could tell immediately with the Splunk query, yes, a file removal did occur. And let me explain, I've had to, eliminate some of the more sensitive data like the timestamp and the filer name and the IP address. But each of those items corresponds to a different field from the event. So our logs basically provide the username, the host name, the time that operation occurred, and the path that operation occurred in. So essentially with all of our filers, we can determine when it's being deleted, who's doing that operation, and where that operation is coming from, which client. So we knew immediately, we splunked, and we were able to say, yes, the file, that path was removed. And we knew who did it and from what host that occurred on. But the next step was really then understanding, well, why did that occur? So in our environment, we also log PS data into Splunk. So on Linux, you can run the PS command, and it will tell you all the processes running on the box. We dump that data into Splunk. So I was able to then use the information from the first bit, the host name, the user ID, to look for the actual process that was doing the removal. Now again, I've had to eliminate some of the super secret things like usernames and process IDs. But that's what the bottom data is here. It's just showing you the process information from a Linux system. And essentially, we were able to see, we knew a file was removed, we knew who did it, what was the command running, in this case, RM. So there was a recursive RM that was run And we knew the user, and that was the process that ran it. So using the process data, we were then able to look up the process data on that host and then correspond that to our job scheduling system. So we knew which job that was part of, and then from that, which workflow that was part of. We worked with those users that managed that workflow, and they indeed had a typo in one of their scripts, so it was by accident recursively removing the highest level directory. The point is that having different source types together allows you to drill into the data and determine what's going on. So step 1, we confirmed there was a delete. Step 2, we found the process that deleted it. And from there, step 3, we knew the workflow that initiated that process and the customer group and the type of job where that occurred from. So really, we're trying to move up the stack and not just look at the IT systems, but better understand what users are doing and the impact in their environment, and helping them build smarter chips. So here's another example here, and let me walk you through this picture. So the top graph is basically the load average for one of our revision control systems over time. The y-axis basically goes up to 25, and then the x-axis is over time. So it's just load over time on our revision control, one of our servers. In our environment, we also log all the commands that are run against that revision control system. So we know what type of commands are interfacing with it and who's doing it. So we can determine, what do you see here? It's a somewhat similar graph. The load was high on our registry server, so we were then able to go look and determine who was running commands against it. We were able to work with that user, have them adjust their workflow, and then you see it sort of dips down right around here. So the changes were successful, the load came down on the server, and response time was back to normal. So it gave us insight into how the users were interfacing with the environment. And we're then working with them to make improvements so it doesn't pound our revision control system so much. So some other wins we've sort of had with Splunk is it breaks down our IT silos. We really have all the different teams talking to each other. You know, the networking guys can see what's going on in the storage space. Storage space can see what the identity folks are doing. The identity folks can understand what the grid folks are doing. We really sort of break down the silos and allow everyone to see the data across all the environments. It gives us improved operations, and a lot of the same data sources have multi-purpose. The same data that we use for the grid operations team, security is interested in that, compliance folks are interested in it, the business intelligence folks can use the same data. So a lot of our data sets really have wide number of use cases. And as I mentioned, we're gaining the engineering workflow insight. So we're better able to understand what are users doing to the infrastructure and how can we work with them to improve their tooling so that it's perhaps more optimal. It allows us to kind of move up the stack at a higher level. And in the end, all these things are really just making it better for our users so they can develop faster chips. One other thing is we're democratizing the data. We're making it available to everybody. So instead of everyone having their little data islands of their own, different groups, we could all see the data together and work from sort of a single pane of glass together. Where are we going next? Well, we put a lot of logs in, but we still have a lot more sources to add. We're still having some outages, and there's still places we don't quite have full visibility, but we need to get the logs in. So we're still working that. Metrics. So we want to make use of the native 7.x metric store. That's a very high performance ability to query metrics out of Splunk versus just traditional events like the process data or some of our other log data like the error messages. The metric store, very high performance, very fast for native metrics. So load on the server, those type of things, we're going to move into the metric store. We're making use of the Splunk ITSI product. Has anybody been to an ITSI presentation? A couple folks? Okay, so ITSI is another product from Splunk. Basically allows you to define KPIs against services and have service scores across the environment. There's some very nice high-level glass tables that you could then present to management. So we're working on deploying that and defining KPIs and making it easy to see all of our IT services, what the status is of those services. smarter dashboards. So today we sort of have a lot of different Splunk dashboards, but we actually have engineering data in Splunk as well. And we want to combine our dashboards and make them even better. So we take some of the engineering data that we have along with our IT data, and then we could really understand an engineer's output, what is going on with the environment, and if there's any IT issues, we could directly then determine how that impacted that specific job and what changed potentially in their job output. So we want to make use of both types of data together. Telemetry. So when I think of telemetry, I think of kind of like heartbeat type information, availability and performance data that's continuous. So response time from servers, response time from networking, all of our type of feeding, constant feeding into Splunk. So we want to make more telemetry sources and bring that into Splunk. And to support these initiatives, we also have some infrastructure upgrades that we're working on as well. So thanks very much for attending. I'm happy to take questions you have. And please, if you provide some feedback and rate in the app, very easy to do in the Splunk app. Yeah. Questions? Yes? So there was a question. Oh, I'll repeat the question. Okay. Oh, could I repeat? Oh. Okay, we're out of time. I guess I'll take some questions over here. Yeah, but I'll be happy to take some questions over here.